Ever get that feeling? Like you're completely hooked by the idea of life out there somewhere, beyond Earth, but then it just hits you how massive that search is. Like, where do you even start?
Right. It can feel overwhelming. You start digging into it, and it's this whole ocean of crazy possibilities.
That's exactly why we're doing this deep dive. Think of it as a cheat sheet, I guess.
A fast track to some of the core concepts in SETI, the search for extraterrestrial intelligence.
But we're not wading into like pure science fiction here. We've got something solid to base this on.
We do. This deep dive, it's all built around a 1978 paper. The title, let me get it right, On Strategy in the Search for Extraterrestrial Civilizations by, and this is important, N.S. Kardashev.
And this guy wasn't just like some armchair theorist, right?
No, not at all. Kardashev, he was an associate member of the USSR Academy of Sciences, and he was leading the lab over at the Institute of Cosmic Research.
So serious credentials.
Serious astrophysics chops.
Okay, so where are we going with all this? What's the mission for today?
So the goal is to unpack Kardashev's ideas, because he really digs into how SETI research was being done back then in the late 70s. He's pretty critical of some of the early approaches.
Like what was working, what wasn't, and kind of the big picture, how we should even be thinking about like the nature of these alien civilizations we're looking for.
Right, if they even exist.
Yeah, exactly. And just so everyone's clear, everything we're discussing, it's coming straight from this paper. No side tangents, no speculation beyond what Kardashev himself lays out.
All right, so picture this. It's 1978, you're a researcher, totally into SETI. What's the scene like, according to Kardashev?
Well, he mentions there were active research groups in both the USSR and the US looking for radio signals from space. And this wasn't like random. This was a coordinated effort following the recommendations that came out of the Soviet American Conference on Extraterrestrial Intelligence, CETI.
So a sense of international collaboration, which is pretty cool.
It is. But, and here's where it gets interesting, Kardashev also points out that the initial results from all this effort were negative. Zilch. Nothing.
Oof. And that must have been, like, discouraging, right? You're pouring all this energy into the search and coming up empty?
You'd think so, but Kardashev actually isn't surprised. In fact, he kind of tears into the whole approach of these early experiments.
Like, what's he saying is fundamentally wrong with them?
Okay, so he claims that these early attempts were just way too small scale. He was more about figuring out, like, hey, can we even do this? Rather than having a realistic shot at actually finding a signal.
He does specifically mention one of the more thorough searches they did, scanning around 600 nearby stars using that 21-centimeter radio band.
Right, which makes sense, hydrogen and all that.
Yeah, yeah. But the thing is, the time they actually spent listening to each of those stars, a couple of minutes.
Think about it this way. It's like you're trying to find a specific grain of sand, a tiny one, and it's lost somewhere on all the beaches of Earth.
Okay, I see where you're going with this.
So you grab a few handfuls of sand, look through them really quick, and then you just, like, give up.
Yeah, the odds of you finding that one specific grain.
Basically zero. It's the same thing here. The chance of an alien civilization happening to be sending a signal on an exact frequency for that handful of minutes with their antenna aimed directly at us, it's ridiculously small. Astronomically small, you could say.
So the tech was limited, but Kardashev, he sees a bigger problem, right? It's more than just the scale of the searches.
Right. He's arguing there was a major flaw in the way they were thinking about the problem.
Okay, get to it, lay it out for us.
The missing ingredient, he says, is a well-defined strategy. Largely based on, well, a deeper understanding of what these extraterrestrial civilizations might be like and what kind of signals, if any, we should actually be looking for.
So where do we even start?
Well, Kardashev calls out this concept he labels terrestrial chauvinism.
Okay, now that's catchy. What's that all about?
It's this idea that we're kind of stuck in our own little bubble. Like, we assume any aliens we might meet would be somewhat like us.
Meaning, like, walking on two legs, big brains, similar tech level.
Exactly. It's basically saying, hey, if there are other people out there, they must be at roughly the same stage of development as we are.
Which, I mean, on the surface, kind of makes sense.
It seems intuitive, right? But Kardashev slams that assumption. He calls it, I'm quoting here, totally unacceptable from the standpoint of scientific analysis.
Strong words. Why so harsh?
He's saying that we're being way too narrow-minded, basing our entire search strategy on this one very human-centered idea. We need to think bigger. We need a much broader understanding of what alien civilizations could potentially be like.
So, if we can't assume aliens are like us, what does Kardashev propose we use to guide our search?
He starts by saying that, look, there's no real reason to believe that Earth or our solar system is anything special.
Which, from what we know about the universe, yeah, that checks out.
Right. He points to all this evidence from astrophysics that shows, the basic building blocks of matter and the laws of physics, they seem to be consistent across billions and billions of light years.
And across billions of years, too. Right.
Exactly. And when we look out into space with our telescopes, we're essentially looking back in time.
Right. Light travels at a finite speed. So the further out you look, the older the light is.
Exactly. And what does that tell us? That our sun is just one average star among like an uncountable number of stars.
Speaking of stars, what about planets? That was a much newer field back then, right?
It was, but Kardashev brings up some interesting points. He mentions how scientists were getting much better at understanding how planetary systems form. Those swirling clouds of gas and dust, they give birth to stars, but they can also form planets.
And he talks about computer models that were starting to accurately simulate the whole process, right?
Yeah, that's right.
Yeah.
But he also brings up a specific piece of evidence that really caught his eye. The discovery of rings around Uranus.
Rings. How do those tie into planets being common?
He saw those rings and the moons around Uranus as kind of like a mini planetary system. It's essentially the same gravitational laws at work.
Like a snapshot of planet formation in action.
Exactly. So it's backing up those theoretical models with like real-world observations.
And he also tackles those multiple star systems, where you have 2 or 3 stars orbiting each other.
You'd think that would be way too chaotic for planets to form.
Yeah, you'd imagine those gravitational forces would just fling everything apart.
But Kardashev, he says, hold on, not necessarily. In some cases, these multiple star systems, they can actually help with planet formation. He talks about these special orbits, resonance orbits, where everything kind of locks into a stable configuration.
He even uses examples from our own solar system, right?
Yeah, like how the sun and a planet and a moon can all exist in these stable relationships. So the point he's making is that these stable orbits, which are probably crucial for life as we know it, they can exist in all sorts of different stellar environments.
Interesting. But he doesn't stop there. He also dives into the building blocks of life itself.
Right. He highlights another big discovery, the detection of complex organic molecules in space. Not just like basic stuff, but complicated molecules. And thanks to radio astronomy, we know they're all over the place.
So the ingredients for life, they're out there.
Abundant, even. And that suggests, a lack of those raw materials. It's probably not the limiting factor for life emerging elsewhere.
Which brings us to the big one, the origin of life. What's Kardashev's stance on that?
He argues that it's not some crazy fluke, not just random chance. Instead, he sees it as this rigorous process, like a natural consequence of complex chemistry happening over long periods.
Driven by the laws of physics.
Exactly. And he points to how quickly that universal genetic code popped up early in Earth's history.
Suggesting it's not like some impossibly rare event.
Right. He completely rejects the idea that a living cell just like spontaneously assembled from individual atoms purely by chance.
He does admit that we're still missing some pieces of that puzzle, though.
Of course, we don't have the full picture of how that first spark of life happened. And he points out that any traces of that process on Earth, well, they're probably long gone, wiped clean by billions of years of evolution. But he felt like biology was getting closer to understanding that initial step.
And once you have life, what about evolution? That progression towards complexity, towards intelligence, maybe even a technological civilization like ours.
Kardashev seems to think that evolution, at least the broad strokes, it might be governed by, again, some underlying natural laws, even if we don't fully grasp all the steps involved.
A kind of inherent drive towards complexity.
Yeah, something like that. It's all about gathering information, processing it, using it to survive and adapt.
Which makes me think about those estimates they were working on with Project Cyclops. How many civilizations might be out there in our galaxy?
Right, that was a big question. And their approach was basically to assign probabilities to a bunch of factors, like how fast do stars form, what percentage have planets, how many of those planets are habitable, and so on.
And all those probabilities get multiplied together, and boom, you get an estimate.
In theory, yeah. But the funny thing is the final number, it really hinges on one super uncertain factor.
And that is?
The average lifespan of a civilization, specifically when it's in that communicative phase. When they have the technology to send out signals that we could potentially detect.
And that lifespan, it could be anything, right? From a few decades, if they nuke themselves, to billions of years, if they figure out how to survive long term.
Exactly. And depending on what number you plug in, the estimate for how many civilizations are out there, it could be billions or it could be just a handful.
He even mentions that group, the Club of Rome, who were not exactly optimistic about humanity's future.
Yeah, those guys were predicting a pretty short lifespan for us. So if you apply that universally, it makes the argument for Earth being the only planet with life a little stronger.
But Kardashev pushes back against that, doesn't he?
Hard. He says, look, there's zero scientific justification for assuming that every civilization just self-destructs after a certain point.
Fair enough. We have our problems, but it's not like we're guaranteed to wipe ourselves out.
Right. He sees those threats, like war, environmental damage, but he also sees them as problems we can potentially solve. So the lifespan of a civilization, it's a huge unknown, and he's not jumping to conclusions.
So if we can't just rely on assumptions about, like, how many Earth-like civilizations there might be, what's the alternative? How do we even define what a civilization is?
That's where things get really interesting. Kardashev dives into some pretty abstract territory here. He admits, look, we don't have all the answers. But he says we can still try to formalize this idea of civilization, and he bases it on something we do know.
Which is?
The fact that the laws of physics, they seem to be universal. Everywhere we look, same rules apply. So he says that gives us a starting point for thinking about civilizations on a grander scale.
Makes sense. And he also points out that compared to the universe, we're pretty new to this whole civilization thing.
Right, our own civilization, especially in terms of like interstellar communication, we're just babies compared to what might be out there.
Which suggests a lot of those civilizations, if we ever find them, could be way more advanced than us.
Potentially, yeah.
Hmm.
But he also suggests that maybe this stage of development where we are now, it's like a necessary step, something every civilization goes through.
Interesting. So what does he actually propose as a definition of civilization? I remember he borrows from that Lyapunov guy who studied life itself.
Right, okay, so deep breath. Here's Kardashev's definition. A civilization at its most basic level is a highly stable condition of matter capable of gathering, abstractly analyzing, and utilizing information so as to acquire qualitatively new information about the environment and itself toward achieving self-improvement of potentials for the obtaining of new information and the working out of preservation reactions.
Whoa, that's a mouthful.
Yeah, he doesn't do simple. But in essence, he's saying a civilization is like an information processing machine, a system that actively seeks out information, understands it on a deep level, and uses that understanding to, like, improve itself and survive.
It's not just about building stuff, it's about learning.
Right, and constantly adapting. A learning machine, but on a massive scale.
And he even includes a diagram in his paper to help visualize this.
He does, figure 1 if you want to look it up. It's a simple model, but it shows how a civilization interacts with the universe. You've got production, you've got all the accumulated knowledge, scientific and social, and then you've got this central program that analyzes everything and guides those productive activities.
And he emphasizes how information is hierarchical, right? Like there are levels of understanding.
Exactly. He uses the analogy of an information tree, and we're probably just scratching the surface, exploring a few low branches. For a civilization to keep advancing, it needs to keep climbing that tree, discover new branches, or connect existing ones with broader theories.
Which raises a question. What if there's a limit? Like, what if there are only so many fundamental laws to discover?
He does touch on that.
Yeah.
He suggests that if we ever reach a point where we know all the major laws, then, well, maybe progress would just become, like, quantitative. Just applying what we know without any big breakthroughs. He even throws out the word boredom.
Cosmic boredom. Wow.
But he also quickly points out we are nowhere near that point. He lists out a bunch of unresolved problems in science, from the really big stuff like a unified theory of gravity or explaining the origin of the universe, to understanding the very small, like the nature of elementary particles. Oh, and figuring out how the heck the human brain actually works. That's a big one, too.
Plenty to keep us busy.
Right. And that leads to his key conclusions about civilizations.
Hit me with them.
Okay, number 1. Civilizations, they have a huge capacity for development and communication. Potentially limitless, because there are so many fundamental questions left to answer.
Number 2.
Our current level of development, it's probably just a tiny fraction of a civilization's communicative lifespan. So we're unlikely to find others at exactly the same stage as us.
And the last one?
And this one's important. He says, highly developed civilizations, they almost certainly know and use laws of nature that are completely unknown to us.
Mind-blowing, and that has big implications for how we search.
Absolutely.
So given how different those advanced civilizations might be, what are some of the models Kardashev considers? He brings up that famous question from Shklovsky, right?
He does. Shklovsky asked, if super civilizations are out there, why haven't they, like, colonized the entire universe already? Why haven't we been swept up in their wave of intelligence?
The classic sci-fi invasion scenario.
Right. But Kardashev, he offers a different perspective. He says maybe unlimited expansion, it's just not a goal for a super advanced civilization.
Yeah.
If the laws of physics are the same everywhere, what's the point of spreading out physically? Plus, those vast distances, they make communication and coordination a nightmare.
He even suggests that they might be more inclined to combine, to share knowledge and resources rather than conquer.
Yeah, that's an interesting thought. And he throws out some alternative activities that might be keeping them busy.
Like what?
Things like super detailed investigations of the quantum world, because that's where things get really weird and potentially very informative. Or long-duration space flights to the most interesting parts of the cosmos, like galactic centers, where there's tons of energy and activity. He even mentions the possibility of studying or even attempting transitions into other dimensions.
Through things like charged black holes.
That's one idea, yeah. Now here's where it gets really cool. He starts thinking about the observable consequences of those activities.
Like, what would we actually see or detect if they were doing those things?
He figures that any civilization doing those kinds of things, they'd need a ton of energy. And if they're efficient, that energy would mostly get converted into radiation, which means we might be able to detect it as a form of blackbody radiation.
The cosmic equivalent of, like, waste heat from their technology.
Exactly. But he also mentions the possibility of detecting their megastructures, things made out of massive amounts of solid matter. And of course, we can't rule out intentional signals. Maybe they're trying to get in touch.
So that brings us to his core argument, the two contrasting search strategies.
Right. The first one, he calls it the terrestrial chauvinism concept.
Mm.
Basically, it assumes that most civilizations, they either plateau at a level similar to ours, or they wipe themselves out.
So we should be looking for more Earth-like signals.
Yeah, coming from planets around sun-like stars, using technology similar to our radio telescopes, and probably sending out continuous narrowband signals.
And the second strategy.
That's the evolutionary conception. This one starts with the assumption that there are civilizations out there that are vastly more advanced than us.
Super civilizations, as he calls them.
Right. And their technology, their ability to transmit signals, it would be beyond anything we can imagine.
Mm.
So the search strategy here takes a different approach. First, you look at the most powerful things in the universe, galaxies, quasars, and you don't just assume they're natural. You only conclude that after you've ruled out all other possibilities.
Including the possibility that they're artificial.
Exactly. And the second part of the strategy, it's about actively searching for completely new sources of energy, especially in parts of the electromagnetic spectrum that we haven't studied as much.
So under this evolutionary approach, what are some of the specific things we'd be looking for?
Unusual signals, for one, like monochromatic or pulse signals, but coming from places like galactic centers or those weird quasars. Basically, anything that looks out of the ordinary, anything we can't easily explain. And it also involves looking for visual evidence of those megastructures. Imagine seeing a solid object, massive, moving at like a significant fraction of the speed of light.
That would be a pretty big clue.
Hard to miss that, yeah. And of course, any new strange source of radiation gets a close look.
And Kardashev, he's pretty clear about which strategy he favors.
Oh, yeah. He flat out says the terrestrial chauvinism approach, it's logically contradictory and hopeless. He really believes we need to focus on those super civilizations and pay close attention to any new, unexplained astronomical objects.
Especially galactic cores and quasars, he seems particularly interested in those.
He is. And it's all about the sheer energy output of those things. I mean, the center of our own galaxy, it's pumping out 1,000,000 times more energy than the sun. And quasars, forget it, they're like trillions of times more energetic.
Hard to wrap your head around that.
Yeah. And he proposes two possibilities. Either those energetic events, they're somehow connected to the activities of advanced civilizations, or those civilizations are figuring out how to tap into those energy sources. Like, imagine harnessing the power of a quasar.
Talk about renewable energy.
Right. And he even thinks about the possibility of them building giant structures in those extreme environments.
Which sounds crazy, but he argues that the density of matter in those places, it's not necessarily that high.
Yeah, so maybe you could build something massive, but far enough away from the central chaos to be relatively safe. And if they're doing that, those structures would probably give off heat. So we might be able to detect that as black body radiation.
The heat signature of a cosmic scale civilization.
Exactly. He also brings up the first stars in our galaxy, the really old ones, the superdwarfs.
How do those fit in?
Well, they tend to be concentrated near the galactic center, and they're billions of years older than our sun. So any civilizations that formed around them, they would have had a huge head start.
Which makes the galactic center a prime spot to search for signs of, like, ancient, super advanced civilizations.
Exactly. He makes the point that understanding those early stars and what's happening at the galactic core, it's not just important for SETI, it's crucial for astrophysics in general.
And that shift in focus from nearby stars to these distant, super energetic objects, it also changes how we think about the best wavelengths to use for our searches.
Right. That 21 centimeter band that we talked about, the one that makes sense for looking at nearby stars, well, that might not be the best choice for galactic centers and quasars. They emit all sorts of other radio waves, and there's a lot of scattering happening.
So what does he recommend instead?
He suggests looking at the millimeter wave band. That's where the background radiation of the universe is at its strongest. And he argues that a signal from a distant galaxy emitted in that band would still be detectable here, even after it gets stretched out by the expansion of the universe.
And that corresponds to a specific wavelength for us, right?
Yeah, about 1.7 millimeters. And that's a sweet spot, he says. It could allow us to pick up both intentional signals and the heat signatures from those big artificial structures.
He also mentioned some specific objects that look interesting at those wavelengths. Short wavelength radio sources at the galactic center, and some infrared sources around get this, near room temperature center.
Sounds cozy.
Right. He also briefly mentions that powerful gamma radiation coming from the galactic center.
Yeah, which does raise some questions about, how would anything survive that? But in true Kardashev fashion, he's optimistic. He suggests that maybe, with advanced enough technology, you could shield yourself from that kind of radiation.
He does have a point. We can't let our current limitations dictate what a super advanced civilization might be capable of.
Exactly. And speaking of limitations, he raises another really important point, what he calls the presumption of the natural character.
Which basically means
That we tend to assume everything we see in space, it has a natural explanation. But he's saying, hold on, don't be so quick to jump to that conclusion.
especially when we encounter something we don't understand.
Right. He argues that we should consider both natural and artificial explanations, at least until we have more information. Because if we automatically assume everything is natural, we might miss genuine signs of extraterrestrial activity.
He even entertains the idea that these super civilizations, maybe they understand space and time in a completely different way than we do.
Yeah, what if they have access to other dimensions or interconnected regions of space-time? We can barely wrap our heads around that stuff.
It's definitely stretching the limits of our imagination.
It is. But that's kind of the point he's making. We need to stay open-minded.
And then he goes on to talk about future technology and how it might revolutionize our ability to detect these civilizations. He mentions that cosmic radio telescope of unlimited range concept.
Right, that was a proposal for these giant space-based radio telescopes, 10 kilometers in diameter.
That's bigger than some cities.
Yeah, enormous. And with those, he says, we could potentially detect civilizations at incredible distances, almost as far as we can see into the universe.
Imagine the things we could discover.
I know, right? And he really emphasizes that this kind of technology, combined with that evolutionary approach, focusing on super civilizations, that's our best shot. Way better than just listening for those faint, Earth-like signals from nearby stars.
So wrapping it all up, what are Kardashev's final takeaways and his main recommendations for SETI research going forward?
He ends by saying, look, based on everything we know from astrophysics and biology and information theory, the odds of there being other civilizations out there, they're pretty good. But he emphasizes we need to rethink our assumptions. We need to shake things up. And he's putting his money on the evolutionary conception. That's where we need to focus our efforts.
And he lays out some specific experiments, right? Things we could actually do.
He does. He says we need to actively search for those black body radiation signatures, the ones that could indicate giant artificial structures. And he suggests using some pretty advanced techniques, like super long baseline interferometry, to get really sharp images and to detect tiny, compact objects. Oh, and of course, the search for coherent signals, the kind that wouldn't occur naturally. That's still crucial. But he thinks the millimeter band, that's the best place to look. And he ends on a hopeful note, saying that if we do these things, if we use the next generation of telescopes and really think big, we could get positive results in the next few decades.
Yeah, it would be incredible.
It would be a game changer.
Yeah.
So that's Kardashev's 1978 paper in a nutshell. We started with those early SETI efforts, which were definitely groundbreaking, but limited. And we ended up with this whole new way of thinking about the search.
It's about looking for the truly extraordinary.
Right. The biggest aha moment for me, it's realizing that maybe we've been too focused on finding something that looks like us. Kardashev makes a strong case that we need to broaden our perspective. We need to look at the most powerful and mysterious things in the universe, those galactic cores, those quasars, and really consider the possibility of civilizations that are so advanced they're almost beyond our comprehension. Because if we do that, the chances of finding them, of finally proving we're not alone, they go way up.
It really makes you think about the scale of it all and what might be possible.
It does, and it leaves you with these, mind-blowing questions. What if these civilizations can harness the energy of entire galaxies? What if they can manipulate space-time itself? What kind of knowledge and technology might they possess? It really puts our own progress into perspective. So I hope this deep dive has given you, our listeners, some food for thought. This search for extraterrestrial intelligence, it's a journey into the unknown, and who knows what incredible discoveries await us.